There are a lot of different ways to build a factory in Factorio. Let's get into it. 1. Geometries. There are two basic geometries we can use for a factory block, the side geometry and the centerline geometry. Neither of these configurations provide any real factory benefit. As long as we have the correct number of machines and the correct speed of belts and the correct number of inserters, then it almost doesn't matter which geometry we choose to use. We could abandon both of these approaches and build pure spaghetti and the factory would still work. But in terms of building a repeatable and consistent factory block, these are the two choices. The benefit of either approach, or even in abandoning them entirely, is purely down to aesthetics. What do we think looks best? That's it. Point 1 in this video, how do we want our factory to look? This might seem like an inconsequential thing. Who cares what our factory looks like? If we were buying a car, we would only care about the mechanical performance of that car. We wouldn't care about how it looked from the outside, would we? The point is, I care, and you better get used to it. In order to get this centerline geometry to work, we need a particular configuration of splitters which can split ingredients left and right and continue along the original conveyor belt path. These are what I call centerline widgets. I have a video all about widgets, link in the description. For the purposes of this video, these are the only applicable widgets we need to worry about. This last one on the end isn't in that widget video. I've only just started using it. 2. Configurations. Let's just separate the factory portion of these two potential geometries. If we remove the bus, what we are left with is the core process configuration. We need to make a thing, and that thing requires a certain amount of other things. How do we deliver and extract all of the things in a way that is scalable and adaptable for a lot of different situations? Whether we're using a centerline geometry or edge geometry or spaghetti geometry almost doesn't matter here. Well, unless you're a complete heretic and want to build spaghetti in here too. There is a limit to how useful I can be if you want to go full spaghetti. Assuming you aren't a full heretic, let's go through all the configurations. Well, all the configurations that are sensible. At the most simple of levels, we have one input and one output systems. Gear wheels, pipes, copper cables, etc. As we move up the levels of complexity, we get more and more options for how to configure these bits of the factory, but for now things are relatively simple. We can run the input down the middle and the outputs outside of the machines. We can run both the input and the output down the middle. And we can do this funky third approach where we bring the input and output perpendicular to each other. I don't generally use this third approach because we still have to bring the inputs into the block. And this extra conveyor belt starts to make things look, well, cumbersome. This approach with both belts going down the middle between the machines is the most area efficient of these three options. It crams more stuff into a smaller space. But the inputs and outputs entering and exiting a block next to each other can be tricky to connect with a bus. I generally try to avoid this situation if I can. So for the most part, one input, one output systems, I use the first configuration. Probably just like you. 2 input, 1 output systems, and we start to have options. We can bring the inputs down the middle and the outputs outside. This is probably the standard approach. We can also mix the inputs so that we have an ingredient on each side of the main input belt. We can bring one ingredient down the middle and the other ingredient perpendicular. We can also swap around any one input belt with the output belt. This is pretty universal for all of these configurations, to be honest. There is no reason why we couldn't take the outputs out through the middle in this example and have an input on the outside instead. Well, there is one reason why we would want the outputs and inputs to be located in specific locations around the assembly machines, and that is long inserters. When we place down yellow inserters in a factory block, we have available options for upgrading them. There are faster versions available. So if there is a problem with throughput that we didn't foresee, we can very easily fix the problem. But with the red long inserters, unless we start talking about quality, which I don't intend on doing in this video, even if I do intend on mentioning it several times, there is no upgrade. It might be possible to squeeze an extra long inserter in if we have the space, but not if there are other things in the way, like other inserters or power poles. There isn't always an easy fix if the bottleneck is caused by red inserters. So for this approach, with both inputs running down the middle, if one or both of those inputs are high volume, then the long red inserters might not have enough speed to meet the demand. There is a fix, and it is this: to place splitters on the input belts, and that gives us the option to not use the long red inserters, because now everything is within a tile of an assembly machine. This is a good fix, and it will work in this situation and in a few others, but it isn't universal. It won't fix every red inserter problem. Just keep that in mind, or at the very least that red inserters being the critical thing in our factory is not fun. 3 input, 1 output systems, and things start to get interesting. For me, for you, and for this video in trying to squeeze everything on the screen. This is where options start to multiply. The standard method is probably to run 2 inputs down the middle and 1 input and the output on the outside. We could also do the same but mix the inputs. We can run 3 inputs down the middle, the outputs on the outside, and then use some inserter jiggery pokery to make sure we can pick up those 3 inputs on the inside. We can run 2 inputs down the middle, outputs outside of that, and then the 3rd input perpendicular. We could even mix the inputs and do the same. And we can also run everything in a grid-like pattern so that every conveyor belt is within a tile of the assembly machine. This last approach might seem a little over the top, but 3 input, 1 output systems in vanilla Factorio are some of the most devious in the game. Railways, low density structure. Railways in particular do not work with red inserters. Every time I have tried, I have failed. The only configuration that has worked 100% for me with railways is this last one, the one that allows us to ignore the long inserters and just use the fast ones. 4 or more inputs and 1 output systems in vanilla Factorio are rare for processes other than factory units like refineries and rocket silos, weapons, vehicles and the like, not processes which we tend to rely on for throughput. If we are playing with mods, then this is almost certainly not the case. Who knows what devious things mod creators have in mind for us, but I would like to think that if that is the environment we have put ourselves in, we should be more than capable of using the fundamentals of what I am describing here to figure out the potential configurations that can be used. That being said, if there is a 4 input, 1 output factory required for a throughput critical process, then this is the factory I would build to do that. I can't think of a sexier way to achieve 4 inputs than this. This is how the increase in number of inputs in a factory process manifests itself in the configuration of that factory. We have a number of inputs and we just select the configuration that matches it. In a very real way, it doesn't matter what the inputs are, only the quantity of them. The ramifications on the rest of the factory are what we expect. We extract the inputs and we provide the outputs. The manifestations that result from an increase in the number of outputs, however, are fundamentally different. The process of building the configuration is mostly the same. For each extra output, we are going to need an extra belt or pipe to remove it. But for the rest of the factory, we now have excess stuff, which we probably don't really want, and which could potentially back up the primary product that we probably do. Now, in vanilla Factorio, there aren't a lot of processes that result in excess products. Oil refining, yes, but we have been dealing with oil refining for a while now, and it's probably well established how to deal with it. Space Age does give us a few tastes, particularly on Gleba and Fulgara, a kilo, Stone on, come to think of it, all of the new planets have some kind of excess product problem. And quality, of course. Quality is almost entirely excess products when we get down to it. These are all topics for other videos. Excess stuff is a video very much in its own right, as is quality, to be honest. The point I want you to take away is that a rise in the number of inputs should just be a case of configuring the right factory block to match the number of inputs, but that a rise in the number of outputs is a much more fundamental factory-wide issue. If you see multiple outputs for a factory process, then be aware there are larger solutions required than just a reconfiguration of a single factory block. 3. Pipes. The introduction of pipes to the configuration of a factory process is broadly similar to that of introducing an extra conveyor belt. It is an extra thing we need to provide or remove from the individual machines, and it occupies a single tile in much the same way. But there are subtle differences, and these subtleties can influence what can and can't be built. In addition, space age now allows us to flip the orientation of factory units, and the effect of this on the design of these small blocks is truly transformational. Let's go through some examples. One pipe in and one pipe out, I'm pretty sure all of us do the exact same way, the only way. Stuff like lube. I don't think there are any options for this configuration other than the obvious. Next, if we introduce a conveyor belt to the mix, then we'll probably gravitate towards something like this, with the input or output placed between one of the pipes and the main factory units, but we can switch things around and run things perpendicular if we choose to. As I'm writing this script, I can't think of any processes which involve a pipe input and output and a single ingredient on a conveyor belt, but if we add another conveyor belt, then we have another recipe I've had red inserter trouble with in the past: sulfuric acid. Sulfuric acid isn't generally critical. For the most part, we don't need a lot of factory units to get the job done, so whatever I build mostly just seems to be enough. But when it has gone wrong, it has gone wrong because red inserters can't insert the sulfur quick enough. Equally, if we are talking about the design of factory blocks, which we are, then the two pipes for sulfuric acid always just seem to get in each other's way. There are ways to get around this. I've built a few on the screen, but the one that I tend to gravitate towards is the perpendicular option with chemical plants running nose to tail. This is a good configuration. There are no red inserters. I like it. It works. So why build anything else? This approach of bringing in pipes and conveyor belts perpendicular to each other I have found to be incredibly useful in a huge variety of processes. Not only that, but it is the most area efficient way of building with pipes. It will result in a smaller factory. I think. I'm pretty sure. If we start talking about two pipe input systems, then this is where the new mechanic of being able to flip the orientation starts to get useful. Let's take heavy oil to light oil cracking as an example. In the olden times, if we wanted several banks of this process lined up in parallel next to each other, we would need a 7-tile gap between the chemical plants to get it to work. We needed 3 pipes, 2 of which were delivering the same thing, and therefore one of which was technically redundant, but we needed it because we couldn't intertwine the underground pipes. We still can't intertwine underground pipes. And then 4 single tile gaps between those pipes. In the newer times, by flipping every other chemical plant so that the inputs match on neighbouring units, we can get that 7-tile gap down to 2, which is literally the limit. We need 2 pipes. This can't be achieved with less than 2 tiles. There is a similar effect with oil refining also. The 3 fluid outputs of oil refining are a lot easier to manage when opposing refineries match each other. Being able to flip factory units has incredible potential for decreasing the size of our factories. This probably isn't the limit, or even the start, to be honest. 4. The numbers. This is not the first time I have made this video. Technically, it is the 3rd time, but the first one was only up for a week or so. There were some pretty serious problems with it, so really it is only the 2nd true version. In the time that has passed between then and now, we have been given space age. I am a man of the numbers. I love them. It's a really, really big reason why I play this game. In old Factorio, that's what I'm calling it now, the numbers that were presented to me were magnificent and precise. I revelled in the accuracy of calculating them and enacting them on a map. To me, the mathematics of old Factorio were a great symphony, and I was its conductor. But we don't live in that world anymore. We live in the world of space age. The numbers of space age are not a great symphony for me to conduct. They are a war of attrition, and they need to be battled and seen to the end. The mathematics of the majority of space age are not fixed. There is a fixed value somewhere off in the distant future that one day we might be able to achieve, but everything up to then is permanently variable. We built a factory yesterday, unlocked a new tech today, and tomorrow the factory we built yesterday will be obsolete. Round and round in circles we go. No longer are we the grand conductor seeking to build the perfect ratio of assembly machines and inserters and conveyor belts and trains and mines in a never-ending pursuit of whatever we consider to be perfection. We are now an engineer, traveling from planet to planet, building the tools that we need in order to unlock the next thing so that we can build the next tool and get to the next planet. We only need the tool. We do not need the perfection. Yet. But that yet is so far away that it is almost irrelevant. The point I'm making is that this is the moment when we depart from the script of the first video and begin down a completely new one. The moment when we move away from absolute and uncompromising precision to a position of, meh, that'll do. If you have seen any of my videos in the last few years, then yeah, this is a radical departure. Space age has shifted my paradigm, no doubt about that. If you haven't seen any of my videos in the last few years, then welcome.
Nothing to see here!
So, how do we talk about numbers then? We can upgrade the productivity of all of the main materials, steel, low density structure, blue circuit boards, etc., potentially to eternity, or at least until we overload the factory. So how do we know what to build today? And this is a difficult question to answer because there isn't really an answer. In old Factorio, absolute and uncompromising precision was absolute and uncompromising. How much fun is there really to be had in that kind of gameplay style? But it was at least a number we could aim at. I have a video on rules of thumb. I'll link it in the description, but this video only applies to Nauvis and can only go so far. Ultimately, the numbers are determined by you, by the levels of productivity you research, by the levels of modules you use, the quality of machines you build with. There are no fixed ratios that apply to all of us. Each save game is essentially tailored to our particular game style, and that might be totally different from someone else's. Like, my numbers are going to be different from your numbers, and they're going to be different from everyone else's. We need to be appreciative of the numbers. That is about as good as I can get in Space Age. At the very least, I would highly recommend downloading a factory planner, but I know people like their achievements. Build a spreadsheet. Download somebody else's. I don't know how anyone gets through this game without any understanding of the maths of it, but I would highly recommend not doing this. The numbers of Space Age are not simple, and to get the max out of your factory, an appreciation of what they are is necessary, in my opinion. Let's put it this way. The mathematics of old Factorio, I believe I could teach to anyone who is able to play Factorio. The mathematics of new Factorio, as of writing this script, I am still struggling to teach myself. There are orders of magnitude in complexity separating the two games. If you are listening to all of this and just feeling completely lost, then do this. Work out what it takes to make 10 of something. Blue circuit boards, for example. How many machines for blue circuit boards do we need to make 10 chips per second? How many for red and green? How many conveyor belts? If we increase or decrease the number 10, do we start arriving at sensible conveyor belt capacities? Then do that for all of the items you are worried about. This is a lot of work, I get it, but all of your steps beyond Nauvis in this new Space Age will be for naught without some appreciation of the maths. This is my belief. Anyway, I've said enough. Once we have some numbers, we can move on to the next step. 5. Investigating the numbers. In a lot of ways, Factorio is a problem-solving game. It sets us challenges, and it is up to us to overcome them. Most of these challenges are simple, straightforward, obvious. Some are all of the above, but some of them are downright devious. A lot of the time we come to understand this deviousness by trial and error. We build a factory. It doesn't work or needs more throughput, so we knock it down and build it better. Rinse and repeat. But if we have a basic grip on the numbers, then it is more than possible to identify these challenges and to prepare for them. There are two particular flavours of devious that Factorio likes to test us with. Flavour 1, super resource intensive. Processes which need a high delivery of input items to maintain a decent throughput. These processes need a lot of belts. Flavour 2, super slow. Processes which take a long time to complete. Low density structure, rocket fuel, Covarex. If we want some proper throughput with super slow processes, then we are going to need a lot of factory units. If we need a factory to deal with a flavour 1 type of process, so super resource intensive, then we are going to need a absolutely silly number of belts in comparison to the amount of machines we're going to need, like this process on Vulcanus trying to make rocket silos. I'm shifting a lot of concrete in this base and it's headed here, don't ask. If we need a factory to deal with a flavour 2 type of process, so super slow, then we are going to need a lot of factory units and not a lot of inputs, like this recipe for electrolyte on Fulgara. A lot of machines, not many belts. The point is that these are the two most devious ways Factorio can challenge us. And so, keeping an eye on these two things, the number of machines required in a process and the number and quantity of materials that are required for that process, allows us to design these blocks with a bit more precision than just trial and error. Let's put it this way. When I'm building a factory block with this new, that'll do approach, I'm asking myself, do I need 50, 100 or 200 machines? Do I need 1 belt per input or 2 belts per input or 4 belts per input? Maybe I need 2 belts for one of the inputs and 1 belt for a different input. That's about as specific as is necessary in this new space age. If we build a factory block and it doesn't have enough units in it, then we can upgrade those units to legendary. We can fill them with speed modules. We can, heaven forbid, bosh down some beacons. If we build a factory and there isn't enough throughput on the conveyor belts, then we can just stack the ingredients better. We have a potential 4 times throughput gain with proper stacked ingredients over unstacked. That is an incredibly useful tool for addressing problems later in the game. All we need to do when we lay down the factory is get it approximately in the right place. Do we need 50, 100 or 200 machines? 1, 2 or 4 conveyor belts per input. And then we just need to build it. 6. Building the numbers. This is where things get subjective. We can't talk about building the numbers without an element of this is how I do it creeping in. I'm not going to talk about bots or trains. In my mind, there is only one way to approach this, but my opinion is just one opinion. When presented with a blank slate and asked to build the same factory, we are all going to do it differently. From my perspective, I like to build neat rectangular blocks of factory. I also like to encase those blocks with paths and walls, but that is a topic for another day. I'd like to think that we all want to build neat rectangular blocks of factory, so that is the approach I am going to present. Here is an empty rectangle. If I am building a factory in this box, then this is how I will basically see it. I need a certain number of machines in the box, and I need a certain number of conveyor belts leading into and out of the box. The area of the box is mostly fixed. No matter how we fill the box, so long as we do it as efficiently as possible, the number of machines we can put in the box should be about the same. Let's say we took the area of this box and made a square that had the same area. The number of machines it takes to fill these two boxes with the same area should be about the same. We are just talking about the area. If we are only able to put 50 machines in this box, but we need 100 machines, then we need 2 boxes. Now, building a factory in a fixed box like this is not an easy thing to do. It will almost certainly lead to a compromise somewhere, either there being the wrong number of machines or in unnecessary gaps. If I am building a critical factory process that needs a specific amount of area, then I would generally try to leave one of the edges of the box undefined. If the only thing that matters here is area, then by leaving one of the edges blank, we can essentially just continue building the block using more area from the undefined edge until the whole block is complete. By leaving one edge empty, we theoretically have infinite area to work with. In this box, we are going to build the circuit board process. Green, red and blue circuit boards. We are going to assume that we are making all of the ingredients for these processes in some other part of the factory. Let's say the bus is on this side of the block, so all ingredients and outputs are going to need to come from and go to here. The first decision we need to make is the order and position of these three processes in relation to the bus. We could place green circuit boards closest to the bus, then red boards, and then blues furthest from it. I wouldn't do it this way because the flow of the green circuit boards, in my opinion, is compromised. They would need to come out of these mini blocks of factory and go left into the main bus and right to feed red and blue circuit boards. If I was building this block, I would build it switched around, with blue circuit boards closest to the bus and greens furthest from it, like this. It just helps to keep the flow directions clearly defined. The green, red and blue circuit board process is also illustrative for another reason. It fully displays the flavors I was describing earlier. Flavor 1, super resource intensive, which is basically green circuit boards. Flavor 2, super slow, that's blue circuit boards, with red circuit boards being somewhere kind of in the middle. This is not an uncommon way that processes are chained together in Factorio. It is very often the case, from vanilla to modded to completely overhauled, for the initial process in a production chain to be the resource intensive one, requiring a lot of conveyor belts, and then later processes in the chain to be much slower, requiring much less material but a lot more factory units. In a lot of ways, the first process in the chain is the most important. If we get green circuit boards right, then red and blues are going to be a lot easier. So if I'm building a factory block, I want to first at least try and identify what the most resource intensive part of that process is, the one with the largest flow of material. It's generally the first one in the chain. I build that part first, furthest from the bus, and then I work my way through the chain, working towards the main bus. If there isn't enough space in the box, then I adjust the ratios of machines or I make the box bigger. If the first process needs to occupy the whole box, then I build a whole box for it. I guess the sequence is, first consider the flows of materials, but don't build them. Then consider the number of machines, actually build those, and then build in the flow of materials that you planned at the start. I guess the overall point I'm making is this. The area that our factory occupies is not just a function of the amount of units in it, it is also a function of good block design. If we are building a factory process that involves multiple steps, then the layout and positioning of the individual processes within that block can be just as important as getting the number of machines or belts right. A lot of the time it is obvious. One process leads to another, and that's how we build it. But I've experienced some devious challenges in certain unnamed packages of mods where the problem isn't a linear set of processes but a series of loops within loops. And being able to build that elegantly within this rectangular block style, encased by immovable walls and paths and railways and such, first time. Okay, I'll accept most of this is just me setting myself arbitrary challenges, but good design is good design. It makes things easier. Hello, post, edit, during, I'm editing the video right now, Bigfoot here. There's a few things that, now that I'm doing this, got the script, wrote the script, editing the video, now that I've done those things and I'm piecing the two together, there's a few things that are coming apparent and I just want to go through. The first thing is that there's a little bit of nuance here that I'm just, building this factory in this block, there's a little bit of nuance here that I did not write into the script that is probably worth including. And the second thing is that when I wrote the script, I had a picture in my head of what the block was going to look like. And so I could, relay certain messages and lessons, etc. And the blocks that I've built is much, much bigger than I anticipated. And so the factory that I thought we were going to see, the one that I was going to refer to, we're not going to see because it's going to be completely different. But, we're in Factorio, and when I kind of get into a problem like this, I just build my way out of it. So we're going to build a factory in here no matter what. It's just not going to be the one that the script was referring to. So I need to kind of address those new ones. I need to cut that bit out of the script and replace it with this one because we're going to be learning slightly different lessons. So the nuance that I wanted to go through was that these two factory blocks that you can see on screen, these are the kind of the starting point. If I was thinking about how I was going to deal with green circuit boards in vanilla, then these are the two kind of orientations that I would kind of, my first port of call. I would build these and see how these would work in the rest of the block. So this one, with 3 conveyor belts going down the middle, I would have 2 of the belts for copper cables. One blue belt of copper cables, that can, 45 copper cables a second can feed 6 assembly machines. So if we want, some reasonable block size, then we really need to tie a couple of these belts together. That's what this one is kind of trying to do. We've got two blue belts of copper cables. They can then be addressed with blue inserters via the assembly machines. And then we can use the red inserters to pick up the iron plate. This would be one that I would think about, but it's not the one that I would prefer, mainly because of those red inserters. Green circuit boards is a critical process. I have had these red inserters go wrong with it, so I would always gravitate to the other one, which is the ones where all of the belts can be addressed with a fast inserter. We're not relying on any red inserters. It's all fast stuff. Now, the problem that this block presents is that neither of these two blocks really fit in here. I could bank a couple of them next to each other. We could bring in the conveyor belts, but there's going to be a lot of gaps. So, in my mind, we can't arrange the blocks like this. We need to kind of pick them up and rotate them 90 degrees and stack them slightly differently if we want to really fill this space elegantly. One of the other things that I had written into the script was that I was going to build half of this block with EM plants and half of this block with assembly machines. I was just to give you an idea of the 2 options that might be available. I've got an opportunity here to show 2 different variants in the north half and the south half of this factory. But the way that I see EM plants is that they're bigger, they're more cumbersome, so we get less options for how we deal with them. Now, you might view that as more difficult, but I see less options as just some configurations aren't going to work. We're gonna have to end up with we just got less options. We've got less ways to play around with this. Ultimately, if we reduce these blocks down to a 1x1 tile, we would have even more options for ways to play around with this. So in my mind, the smaller the unit you have, the more options you have, the more different ways that we can lay this out, the more difficult it becomes. That's the way that I see this. But I suppose that's just a point of view. What I'm going to do differently is, because of the size of the block, I'm going to do something that I normally do with these vanilla factories, is I'm going to deal with the copper cables on site. So I'm going to deal with half of the factory we're going to bring in the copper cables, and those copper cables are going to be made somewhere else in the factory. And then another half, we're going to just bring in raw copper plate and make the copper cables on site. And we're going to see how that works out with this factory. Now, I have actually built that factory already at this point. So what we're going to do is I'm going to just zoom forward 30 seconds to the point where the next bit of nuance needs to be talked about. Alright, so here we are a little bit later in the process, and if you were asked to ask my opinion of this block as it currently stands, then what I would probably say is that the top half with no copper cables, that's probably going to have way too much space there. We're going to have some gaps, and the bottom half where we are dealing with the copper cables, we're going to have no gaps at all. In fact, we're going to be shy on space probably. Don't know yet, haven't built it in. Now that is kind of the point with what I said earlier, when if I was dealing with a critical process and I would consider this to be a critical process, then I would be leaving one of these dimensions completely empty to give myself a little bit more flexibility with how I laid it out. If it's not unreasonable for the size of our factory to be determined by a critical process. So if I was building this factory, I would be putting this in a specific location where I would have certain freedoms to be able to, you know, build the factory around it. But that's by the by. What I really wanted to get to at this point was conveyor belt layouts. So I have a picture in my head of the ideal conveyor belt layout. If we go back to an empty block, this is kind of what I have in my mind when I'm trying to route conveyor belts through a block. This is kind of the way that I want to do it. I want the belts in the middle to go to the furthest processes, and then I want the belts outside of that to go to nearer processes, and I want to kind of scale it back that way. I don't want there to be the kind of lot of intermingling between these belts. But, you know, most of the time, in fact, probably all of the time, this kind of ideal layout is not realistic because a lot of these belts go to different places. You know, if we think about this block that we're dealing with here, green circuit boards are going to come out, they're going to go somewhere in the middle of the bus, but they're going to have to come out and feed red and blue circuit boards, and that really kind of breaks this fundamental paradigm. But it is the default thing. So I will build this kind of fundamental layout first, you know, dealing with the big processes first. You know, ultimately we got these big chunks of belts, and it's even bigger for the copper cables because we've got so many copper cables. We would need so many copper cables to bring in here. You know, this takes precedence. Dealing with these first is most important, and that's what generally tends to happen with these flavor one types of processes. We got so many belts. Dealing with those first is just so much more important than dealing with anything else. You know, we can adjust the sizes of these other blocks much easier than we can adjust the size and positioning of something like this. So when I want to deal with the belts, I will deal with these ones first, bring them through, and then I want to build these blocks around those belts. It kind of breaks the fundamental paradigm of my script. You know, I kind of built the script in a very different way to show a different thing, but we are where we are now. So I'm going to whiz through and build the rest of this base. We're not going to have enough space down here. I've got an idea for how I'm going to deal with this. We're going to have some gaps up here. You know, if you go through my factories, it is not unusual for me to have gaps here, very, very close to the bus. You know, where another process has ended. And I don't necessarily see that as a bad thing. You know, these spaces closest to the bus, these are the most valuable spaces in this block. You know, if we use all of this space, fill it up with belts, and there's still some space left, then we have complete freedom to bring any of the ingredients into this bus, into this block. You know, we can build a process completely different from what we already have in here. It's free space. If there's something we didn't think of, something we didn't foresee, just any potential eventuality that we just didn't consider, this is just invaluable space. I can't tell you how many times this space has got me out of jail. You know. Anyway, let's finish off the block and let's see how it pans out. Because at this point, I actually don't know how it's going to work out. So let's see how it goes. And there we have our finished block. And of course, neither of the halves is perfect, not even remotely, to be honest. You know, the south half, this is nowhere near enough assembly machines for the blue circuit boards. You know, in order to get to squeeze in the copper cables that I need for these red circuit boards, I needed to kind of crop them a little bit. We couldn't quite get them in here. I mean, yeah, it's tight. I couldn't quite get them in there. Anyway. That's what was necessary to get this to work. So, I mean, if this was me and in a proper factory and this is the setup that I had made for circuit boards, this would be a failure. I would consider this a huge, huge failure. If I was doing this in some package of mods and this was some other process, not necessarily as critical as circuit boards, then I would probably accept it if, you know, we have some higher tier modules that we can use and or some higher tier machines. that could solve this problem with this not being enough here. With the top half, yes, we fitted it in. We've got a nice gap here just in case we find a process we need. But ultimately, bringing in this many copper cables, I don't like that idea. I also see that as a failure. You know, copper cables, the main concentrated flow, all the quantity that we need is all coming to green circuit boards. It's not really going anywhere else. So why make copper cables somewhere else? If they really need to be made here, at least the copper cables that we need for these processes need to be made here on site. So I mean, all in all, I think I've demonstrated what I was trying to get at. You know, if we have a critical process that we care about, then we need to build our factory around that critical process and not the other way around necessarily. But if we do find ourselves in a hole somewhere like this, where we've got to squeeze in a factory, somewhere along the ways, we're going to be making a compromise. Nothing is ever really perfect. I did just make a little blueprint of this setup because a thought occurred to me was that, well, I made this huge jump in logic that this was going to create some unacceptable gaps. So I think I was looking at it, let's test it out. So this would have left like 5 or 6 gaps. You know, it would have left a bit of space here. That wouldn't necessarily have carried on all the way down. But that would have been that's the compromise, I suppose, where you're accepting your gaps. Also, one other thing to note, I haven't actually been able to quite squeeze in everything. I kind of messed up a little bit. I put copper cables up here for red circuit boards. I had this idea for a way to squeeze in copper cables into this block, and I just kind of got carried away. So I haven't fed in the copper. There's no space in here to bring in the copper plate. Now, the thing is, this is actually a eminently solvable solution in the real world, because in the real world, this would be reflected around here, and some of these belts we could dual purpose. Like I could take this belt out here, for example, and use it on the bottom and switch it both ways. And that would create some gaps, so I could join together like the red circuit boards. That doesn't need 2 conveyor belts. You know, in this setup, we have a conveyor belt here which removes red circuit boards. And if we reflected it, we'd have the same again. We don't necessarily need that. We can join them together. So there are some savings, but, you know, all in all. Anyway, let's move on with the rest of the video. I need to re-get into the script. Maybe I should do that YouTube thing, you know. Introduce a beep in the middle of... So when we build the conveyor belts to a block like this, we do so from the back, working our way forwards in the block. We start with the belts for green circuit boards. They go in the middle of the bus. Then we deal with the belts for the red circuit boards. They go adjacent to the first belts. And then we do the same for the belts for the blues. The pipe for sulfuric acid. There are 2 basic approaches with the pipe that I like to use. Either I put it in the main bus, probably somewhere where a gap has naturally formed which can't be filled with a belt. I basically use the pipe to fill a gap. Or I bring it along the edge of the block and keep it well out of the way of any conveyor belts at all. Sometimes belts and pipes just don't work well together, and this removes any potential for awkward collisions. If nothing else, it's always good to have options. Technically, what we are doing here is using a centerline geometry for the main belts and an edge geometry for the pipe. So I suppose there is nothing stopping us from doing the same with belts, pushing some of them through the middle of a block and pushing some of them around the edge. I had not thought of that potential until this very moment, writing the script, of using both a centerline and an edge geometry in the same block, maybe for particularly devious recipe change. This needs further investigation. 7. The maul. We are going to get fully subjective here. In throughput critical areas of the factory, it makes a lot of sense to put all of the materials on conveyor belts. It is the most efficient way of moving material around a factory for a lot of reasons. But in the shopping mall, there are compelling arguments for using other methods, particularly bots. And so this section is really just about my particular version of mall design. You know, it is what it is. Big processes need big blocks. In areas of the factory where we need a lot of machines, we need to allow a lot of area. Robot coverage is less important. If everything is on a conveyor belt, then we don't necessarily need continuous robot coverage. The mall is different in both respects. For most of the stuff we make in the mall, we only really need a single assembly machine. We might choose to build more than one machine for a variety of reasons, but from a necessity standpoint, one will mostly get the job done. We aren't talking about hundreds of machines per process, we are talking low single digits. And pretty much all of these processes will need to have robot coverage. These are the fundamental tools of the game. We are going to need the outputs. The factory is going to need the outputs. Other planets are going to need the outputs. Small blocks are the order of the day. But the fundamentals of the big blocks are also relevant. This is the ideal array of conveyor belts. It doesn't change for small blocks. If there are any resource intensive processes, then these are placed at the back of the block, furthest from the bus. That also doesn't change for small blocks. In the olden times, I used to place gears, pipes or copper cables here, and that is how I grouped items in these small shopping mall blocks. Processes that needed copper cables would be placed in the same block. Processes which needed pipes all went in the same block. Pretty much every other mall process would need a gear. All of those simple, resource-intensive processes went at the back of the block. Things are different in space age, but the principle remains. We might need to build factories in places where there is no moltenized iron or copper. The olden ways aren't entirely irrelevant. Once any resource-intensive processes have been constructed at the back of the block, for me, it's really just a case of trying to build in a way that conserves as much area as possible. I want to sequence the factory so that neighbouring processes share the same inputs and can therefore share the same conveyor belts. Duplicating these belts wastes space and makes the bus more complicated. I also like to build 2 assembly machines with a gap down the middle. Some of the processes in the shopping mall use other processes in the shopping mall, and this gap down the middle is not only useful for putting the robot storage chests for the items, but it's also useful for transporting these inter-factory items without having to exit them into the bus. I like to think we are upgrading inserters and assembly machines, not necessarily constructing them, and these belts that run down the middle are for units being upgraded. Minor point. Next. How we group items in the mall is probably the most subjective topic I could address in a video like this. There will be things we all put in the mall. Inserters, conveyor belts, assembly machines. There will be things that some of us put in the mall. Batteries, engines, maybe low density structure. I started out by putting batteries in with oil production, but at some point they migrated into the mall. It's completely different for all of us. I used to group items in the mall based on whether they were gear, pipe or cable based. This matched with how I actually wanted to build them all, and I liked the thing this method produced. Now, there are a lot more options in space age, and all of these items can be produced at much greater efficiency with foundries and molten iron and copper, and so there might be reasons for altering this kind of grouping approach. But I haven't. Probably won't. I like my mall. I'm guessing you like yours too. 8. Tricks. Without underestimating your skill level or intelligence, I can appreciate this might seem daunting, squeezing yourself into a block with little to no room for manoeuvre. I can tell you from experience that needing to put a particular factory in a particular block and finding that I am one tile short from perfect is incredibly annoying, but there are some tricks. For a start, don't try and build in enclosed blocks like I showed earlier with the circuit boards. Start with just a simple corner and construct the first parts of the factory in the middle, far away from any of the edges. Trying to build tight against these edges first time is confining and limiting. If we build the block in the middle, finish it, and then move it into the corner, things do get easier. For big blocks, symmetry. From an aesthetic point of view, symmetry is good, and from a factory point of view, symmetry is good. Having common conveyor belts line up with each other from opposing sides of the factory is incredibly beneficial in keeping the bus simple. When things don't line up, that is when we run the risk of something needing to intertwine with something else, and this is never not bad. I hate intertwined belts so very much. When we build symmetrically, we only need to construct half the block. We can then copy that block, reflect it, place it somewhere, not in the final place but in the correct line, build the entirety of the bus and then move that half into its final position. There is a part of me that feels like these tricks are obvious. I will continue. If we are building symmetrically and we find ourselves making a mess in the bus, then just build each half of the factory entirely separate from the other half. Define a center line somewhere and reflect not just the factory units but the bus as well. We do have these centerline widgets which are able to create the flows we need to make a centerline geometry work, but these are bulky and cumbersome and can easily get in the way of other important junctions. A series of splitters on a conveyor belt which only divert materials in a single direction is an easier configuration to build around. If we aren't sure how the size of this block interacts with the size of other blocks in the factory, then just don't enclose the edges. Leave them blank until those other areas are completed. Try to match those other blocks to this block. Maybe add a few gaps here or there. Add or remove an assembly machine. If we are following this approach of, that'll do, then me personally, I'd take plus or minus 10% of what I was aiming for with any of these numbers. I appreciate I am verging on the heretical territory here, but Space Age has presented us with a mathematical mess, and I am just responding in kind. 9. Conclusions. No fear. It is a mantra I come back to often, not just in Factorio, but also in life in general. There's a line from the film Three Kings.
The way this works is, you do the thing you're scared shitless of, and you get the courage after you do it, not before you do it.
And it's true. I have been playing this game for some time now, and pretty much for the entirety of it, I've been trying to squeeze these factories. What is the smallest footprint that is possible? How do I manipulate that to fit into certain predetermined blocks? How do I bend Factorio to my aesthetic needs without compromising the factory's performance? And I did this without caring one little bit whether I worked myself into a corner or fucked up or whatever. One way or another, I backed myself to get out of any problems I put myself in. Or just make a mess, learn from the mistake and go again. The factories I build are a consequence of that eternal quest. The factories you build are a consequence of your internal quest. What kind of factory do you truly want to build? Don't just build the factory you think you should build, because the lessons you learn won't be your lessons. If you go out there and doggedly pursue your own course without any fear of failure, then over time you will learn the lessons that are important to you, and the factory you build will represent that. I ended my first Sexy Blocks video with a call to sexy arms. What is truly possible in this great game? The only thing that has changed in the meantime is Space Age, and it is no small change. The strategy options are vast, the production chains devious, the potential for new sexiness massive.